Hey guys, as always, I ran out of time with this class. I don't know why I can't get through our lessons, but I just wanted to make another quick video just to make sure I have covered all of the problems you'll have to answer in tomorrow's assignment. So we got to this problem over here. So when you set up your proportion, make sure you put corresponding sides. So in other words, 3 goes with 5, 3 goes with 5. So make sure you start with this one on top of the second ratio because I started it that way. If I flipped it, if I did 5 over 3, that's okay. I would just have to make sure I did x over 4. So however you set up your first ratio, you got to set up the second one in the similar way. So 4 goes with x. So we would cross multiply. 5 times 4 is 20. 3 times x is 3x. And when I divide both sides by 3, x is equal to whatever that is, 6.7. 6.6666666. All right, scale factor of a map is 2 centimeters to 15 kilometers. Okay, so find the actual distances. So if we're going to do 2 centimeters to 15 kilometers, where will these centimeters all go? If we do centimeters on top, we got to put 8 on top here. Okay, so we'd cross multiply. 15 times 8 is 120. And then 2 times x is 2x. Divide both sides by 2, and x would be 60 kilometers. All right, you're going to do the same thing for these two. Everything's going to stay the same except for this number. This is going to be 1.3, and then it's going to be 24.4. You're going to cross multiply and divide. On the bottom, scale factor has half an inch represents 10 feet. So half an inch. So I either do 1/2 or I just like decimals instead. 1/2 is equal to 0.5 inches over 10 feet. This supposed to be a 10. All right, inches over feet. Find the length of the drawing for the actual length. So where does our 20 go this time since it's feet? Well, feet we put on the bottom. So we would cross multiply. 20 times 1/2 is 10. 10 times x is 10x. We divide both sides by 10. And the first one would be 1 inch, 1 inch. Okay. This stays the same. The rest of them stays the same. The only thing that changes is this number. So then we make this a 15, cross multiply and divide. Then we do a 45 over here. Alrighty. So what about this one? Here is a scale drawing. So here's our proportion right here. 2.5 centimeters, 2.5 centimeters goes with 5 feet. 5 feet. They want to know the actual dimensions of Jackie's room. So the actual dimensions would be feet, right? A big room has dimensions of feet, not centimeters. Centimeters are tiny. So how would I get all of these numbers? Well, centimeters, I'm going to put the number they give us right here on top over x. We don't know the actual feet. So to do all these problems, you would cross multiply 5 times whatever number this is, 5 times this number, and then we would divide by 2.5. Divide by 2.5 for all of those. All right, look at these two math problems. You will find this helpful when you're doing tomorrow's assignments. If an architectural blueprint shows a building that's 14 inches tall, so a little building, and in real life the building is 154 inches tall, what is the scale factor used to draw the blueprint? So to draw the blueprint, that's when we're going to take something big and we're going to make it smaller. Big to smaller tells us our scale factor is less than 1, less than 1. So when you go to set up your proportion, which one's going to give you a number less than 1? If we do 154 divided by 14, 154 divided by 14 is 11. Is that less than 1? No, we'd have to do the opposite. we'd have to do 14 over 154, which is an 11, but it's 1 over 11. We can divide both of these numbers by 14. Okay, 1 over 11 to draw the blueprints. That means we have to start with the big and make it small. The second one, if a model airplane has a wingspan of 15 inches and the wingspan of an actual airplane is 14 feet wide, what is the scale factor? So the model airplane has a wingspan of 15 inches and the wingspan of, so we're going to go from small to big, small to big. So we want to know how much bigger is the actual than the small blueprint. Well, the problem here, you guys, so first of all, small to big means bigger or greater than 1 or 100%. So if we did 15 over 40, so first of all, if we're going to just do a division problem like this, our units have to be the same. So if we have a little bitty 15-inch wide wingspan, we're going to have to convert 40 feet into how many inches? If we're using inches here, we got to turn this into inches. Well, how many inches are in a foot? 12. So 40 times 12. 40 times 12 is 480. So now we're comparing 15 inches to 480 inches. How much bigger is 15 or 480 than 15? Well, to get a number bigger than 1, our big number has to go on the top. Has to be greater than 1. So 480 divided by 15 is 32. Our scale factor is 32. In other words, our big plane is 32 times bigger than our model airplane. All right, so we have a rectangle. What is the area and the perimeter as it is? Well, area, remember, is length times width. So 15 times 6 is 90. And then the perimeter is, we have 2 sides that are 15. So remember, perimeter, you add all the sides together. 15 plus 15 plus 6 plus 6 is 42. All right, if we're going to draw a new rectangle with a scale factor of 200, 200% is equal to, if we move our decimal 2 places to the left, our scale factor is 2. 2 is equal to 200%. So that means our new rectangle is going to have to be twice as big, which of course I don't have enough room, but pretend like I do. 15 times 2, this side's 30, and 6 times 2 is 12. So our new dimensions are 30 by 12, 30 by 12. So now we're going to find the new perimeter. So we would do 30 plus 30 plus 12 plus 12, and we would get 84. Oh, wait. I'm sorry. That's the perimeter, 84. Yeah, which is twice as big as 42. 84 is twice as big as 42. But for area, it's not going to be twice as big because we doubled both sides and now we're multiplying them together. So now we're multiplying 30 times 12. So the new area is 360. It's actually 4 times bigger than our original, right? Because we're multiplying 2 things by 2 and then multiplying them together. All right, so then for these problems, we're just doing the same thing. We would find the area and perimeter. So 8 times 3 is 24. And the perimeter is 8 plus 8 plus 3 plus 3, which is 16 plus 6, which is 22. And now for all of these, we would turn all of our percents into decimals, and to get the new dimensions, we would multiply. So 1.2 times 8, 8 times 1.2 would be 9.6. So it's got to be bigger. It's more than 100%. 9.6. And 3 times 1.2, 3 times 1.2 is 3.6. So then to get the new area, we're going to multiply 9.6 times 3.6, and we'd get 34.56. And then for perimeter, we just add all of our 4 sides together. 9.6 plus 9.6 plus 3.6 plus 3.6, and we would get 26.4. Okay, so remember, even though the number is smaller than 100%, that means our new dimensions are going to be smaller. We're still multiplying by 0.6. So 5.6 is 3 and 2.6 is 1.2. All right, we're going to multiply each of these numbers by what? By 3. And we multiply each of these numbers by what? By 0.4. So these numbers are going to be smaller, and these numbers are going to be 3 times bigger. All right, I hope that helped. Sorry to rush through, but you guys have a good day. And if you need any help from me, let me know, and I will check in with you guys later.